Hey, Scott.
Hey,
How are you?
I'm good. How are you?
Good, thank you. I was just going to start working on the review sheet. If you're good with that.
Just chapter 5 one.
Yes, sir.
Okay.
Um, that's what I did before, and I actually, to be honest with you, oh, my stylus is missing. That's not good. I'm looking for my stylus, which will help me to write better. If you have particular questions over the review sheet, I can start there. What I did in the first math lab is I actually started at the end and then worked my way forward, just because it seemed like most people had more questions about the newer concepts than the later ones. But if you have already started working on it and you have a specific question, I will be happy to address that first.
Yeah, I think I'm all right. Uh, Usually it's not, anything specific about the concept. It's just sometimes I mess up with the algebra issues, just
Ooh. Well, you and I will have so much fun because you can double check me on all of my algebra because I've already done that a couple times today. Seems like I mess up less when I'm writing on paper, but when I write on the whiteboard or when I write on here for math lab, I don't know. It gets squirrely for me.
yeah, it does.
So you can kind of watch and be like, oh, hey, Miss Sparks, you multiplied something or you left something out. So just let me know. So I'll
Okay.
just start with 20 and
Okay.
talk through the process. On number, oh, these are from the other day. My apologies. This is not the review. I believe this is the review. In the prior math lab, I had some students who wanted me to work through the worksheet from Tuesday as well. So once we got done with some of this, we worked on that. So I'll start with 19, and just kind of how I approach these when I'm doing them is I like to, because what you want to do on the rational equations is to make sure everything's factored, because you want to multiply each side of the equation by the least common multiple or greatest common denominator, however you like to think of it. So the only thing that's really factorable here is that 3a plus 6, and that actually would break down to 3 times a plus 2. And the good news about that is that a plus 2 is in one of the other denominators as well. So what we'll do to get the least common multiple or greatest common denominator, I don't know how you like to think about it, but
Yeah, I usually just multiply it, or I always just try it, like multiply it by what it takes to get, I guess I find the least common multiple and just,
yeah,
multiply by what it takes to get there.
yeah, good job. Good way to think of it. So you'll just include all the factors, which in this case is going to be 3 and a plus 2 and a minus 7. So you'll do that to both sides of the equation.
Okay. This is super weird. Am I just talking specifically to you, or can everybody hear me, or
If
what's
other
going on?
people jump on, anybody could hear you. So if that makes you
Oh, hey,
uncomfortable,
Chris.
you can actually mute your microphone. But the downside of all of this is that I won't. I cannot see. Sorry about that. I cannot see the chat bar when I am.
You can also turn the camera off in the middle at the top where the mic is. If you want to do that, Scott.
Okay, yeah, okay. I can see I can turn my mic off and I can turn my video feed off. And okay, yeah, now I'm actually seeing the worksheet.
Okay.
Okay, sorry. This is just my first time doing this, and I'm.
Oh, no, that's okay. We got to work out all the struggles. Is everybody seeing the worksheet okay? Because sometimes what can happen is when somebody talks, it actually goes to your camera or your default Google picture. So can everybody see the worksheet?
Yeah, I can see it.
Oh, yeah.
Okay.
Yep.
The only thing is, and I don't know if you mind being this for me, Scott, but I need a volunteer because I can't see the chat box. If somebody has a question and they're shy about asking it via the microphone, a lot of times they'll type it into the chat box, and I just need somebody to say, yo, Miss Sparks, somebody had a question kind of thing, because I can't see the chat box.
Is this
Yeah. I don't see the chat box either.
What review sheet is this? Was this the one we got yesterday in class?
No,
Yes,
this is the one that's not. Yeah, this is the one that's not multiple choice.
This is the one. She handed out a multiple choice one that was classwork yesterday, and she handed out one that was just a non-multiple choice that we were going to use for math lab today. So that's that one with not multiple choice on it.
All right.
19 questions.
Yeah, I got it. Thank you.
No problem. And I'm starting. I don't know when anybody else jumped on, but basically I'm starting at the back and working my way forward just because it seemed like most people had more questions about the newer concepts that we've covered than the latter. So that's why I'm starting with that. So I'm starting with number 19. And basically thus far, to kind of catch everybody up, is we've factored the denominator to make sure that we're including all factors in our least common multiple / greatest common denominator, however you like to think of it. And we found that the greatest common denominator, least common multiple, is 3 times a plus 2 times a minus 7. So the first thing that you'll do, and why you multiply both sides of the equation, is to kind of eliminate your denominator in order to have a more simple linear expression that's a little more user-friendly to solve for the variable. So now where we are is we're multiplying the left-hand side by this greatest common denominator. So what we're looking at is 3 times a plus 2 will go into 3 times a plus 2 times a minus 7. And where it will make the 3 and the a plus 2 cancel out, leaving you with your a minus 7. And then a minus 7 times 1 is a minus 7. And so then I'll move over, and I usually keep things in parentheses just to make sure that, particularly on subtraction ones, that I'm distributing that negative to everything that needs to be distributed to in that second half. So now a minus 7 goes into that least common multiple, 3 times a plus 2, a minus 7. And actually what's left is the 3 times a plus 2 equals, and then on this left-hand side, the a plus 2 goes into the 3 times a plus 2, a minus 7, and leaves you with a 3 times an a minus 7 on the right-hand side of the equal mark. So now I'm going to distribute this is actually thought of as a -3. So -3 times a is minus 3a. -3 times 2 is, oops, my bad. There's one of those simple mistakes, Scott, that I was telling you about. Minus 6 equals, and then 3 times a is 3a, and 3 times a -7 is -21. Does everybody see where I got to that part?
Yeah.
Yeah. Oh, three? You're just taking a denominator number, not the stuff in the parentheses, right?
Yes, that's it. It's kind of like what this actually looks like is very similar to what we were doing in 5.4, where you were multiplying the rational expressions, where you factored things and looked for stuff to cancel out.
Okay, thank you.
No problem. Good question. Now you're going to combine like terms. A minus 3a is going to give you a negative 2a. And then negative 7 minus 6 is minus 13 equals 3a minus 21. And then I'll subtract 3a from the right side to combine it with the left side, which is going to give me a negative 5a. And then I'm going to add this positive 13 to the right side. And so that's going to give me a negative 8. And now I'm going to divide both sides by negative 5. And that actually gives me a positive 8/5.
Okay, we got that.
Yep.
The final step where it says in the instructions, solve each equation, remember to check for extraneous solutions. What that means is this A equals 8/5, which I'm going to write over here just so that I can show you guys on this side over here. What you're essentially doing is you're going to want to plug that 8/5 back into the denominator to ensure that you're not going to get a negative, because then that would be an extraneous solution because you can't divide by a 0. But in this case, 8/5 works fine in the denominator. It's not going to make any of those denominators a 0. So it is, in fact, an okay solution. But that's what extraneous solution means, is you don't want that denominator to be a 0. Does that make sense?
Yeah.
Yeah. Do you usually actually have to plug it in, or can you usually just look at it and tell?
9 times out of 10, you can usually look at it and tell. I can't think of, I hate to always say beyond a shadow of a doubt, you don't have to plug it back in, but I've never had a situation where it wasn't really, really obvious to me thus far. I mean, in this case, to give you if our answer had turned out to be a -2, that would be very apparent that that's not going to work, because on the right side here, obviously that would give you, a 0. It would be a case like that.
Okay.
Good question. And if I've done all 4 of these a couple of times today, and there wasn't a situation where it turned out to be an extraneous solution, I don't think. The other day on that worksheet that we had for Tuesday's math lab, there was one or two that had extraneous solutions to them, but they were very obvious on it. Okay.
Okay, thanks. That worked. That helps.
Oh, no problem. All right, on number 18, once again, it's just easiest to go ahead and factor to make sure each one is in its, lowest terms, so that you can make sure that you're including all factors in that least common multiple, greatest common factor. So I can actually take a 4x out of this, and that's going to leave me with x plus 3. So the good news about that is both of these factors appear here and here. So technically, the least common multiple is going to be the 4x and then x plus 3. And you'll multiply both sides of the equation by that. And so what you're looking at is 4x goes into 4x times x plus 3. And leave that 4x, those cancel out and leave you with an x plus 3 times the numerator. And in this case, it's just a 1. So you have x plus 3. And then minus, and then this x plus 3 goes into the greatest common denominator, and the x plus 3's cancel out and leave you with a 4x. So 4x times 1 is 4x. Equals, and then on this side, that whole 4x squared plus 12x is actually the greatest common denominator. So it leaves you with just that x minus 5. It stays all by itself, stays there. And now you'll combine like terms. That's going to give you a negative 3x on this side, plus 3 equals x minus 5. I'll bring my x over to the left-hand side by subtracting x from the right, and that's going to give me a negative 4x, and take my 3 and subtract it from the left side and bring it to the right. That's going to give me a negative 8. Divide both sides by a negative 4, and that gives me x equals 2. And once again, you would want to plug that 2 back into the denominator in order to ensure that you're not going to get a 0 in the denominator, and you don't anywhere. So it is not an extraneous solution. So 2 works for it. Any questions? All right, should I move on to 17, or is there others on this worksheet that y'all would rather see done?
I'm good if you just went to 17. I don't know about everybody.
Okay. All right, cool. Then
as long as you just move through it, we'll hit all our questions. So.
Okay, great. That's what I'll do. Okay, the least common multiple or greatest common denominator for this one. Does anybody want to take a guess?
5n.
Did somebody say 5n? If you did, that's correct. I couldn't really tell. 5n is the least common multiple for this one. That 1 that's all by itself, you just kind of got to think of it as 1 over 1 as having a denominator. But if I multiply this side by 5n and the other side by 5n, 5n goes into 5n one time, and then 1 times 8 times the numerator is just going to leave me with 8n plus 8 equals, and then this is 1 over 1, and 1 goes into 5n times. So 5n times 1 is 1. Minus, and then 5 goes into 5n with an n left over. So an n times 1 is n. And y'all stop me if you have any questions. Just combine like terms. That's going to give you 8n plus 8 equals 5n minus n is 4n. And I'll bring my 8n over to the right, and that's going to give me a negative 4n. And leave me with an 8 on this side. Divide both sides by negative 4. And that's going to give me n, or negative, n equals negative 2.
Yeah, I got that.
And once again, you would just want to check that. Okay, moving right along. Anybody have a guess as to what the least common denominator is going to be for number 16?
2n.
Anybody have a guess?
N squared.
N squared. Good job. So I'll multiply both sides of the equation by n squared. N goes into n squared with an n left over. And n times 1 is n. N goes into n squared with an n left over, and n times 4 is 4n equals, and then n squared goes into n squared one time, and 1 times 4n minus 3 is 4n minus 3. Combine like terms. Then solve by bringing your 4n from the right to the left by subtracting 4n from both sides. That's going to give you n equals negative 3. double check your -3 plugged back into your original equation. And if it gives you a 0 in the denominator, that would be an extraneous solution, but there isn't, so you're good. N equals -3 is correct. I will say these were a lot simpler than the ones on the worksheet that we had on Tuesday. So if you need me to review any from the worksheet on Tuesday, I will be happy to do that at some point. But we'll just keep working through this worksheet for now. On number 15, in order to solve this, you're going to have to get a common denominator. The difference between 16, 17, 18, 19 and the ones prior to that is obviously the 16 through 19. It's an actual equation. So you're solving for n. On the ones prior to that, you're actually combining two rational expressions. So you'll have to get a common denominator and then combine like terms. So that's how they differ. On number 15, the common denominator, once again, the first thing that you're always going to want to do is make sure that each denominator is in its lowest factored form. And in this case, n-4 and n-5 are in their lowest factored form. So you'll multiply. Typically, how I set these up is I make this really long, kind of obnoxious fraction bar to make sure I'm incorporating all of my factors. And in order to have a common denominator, I'm going to multiply n-4 times n-5. And whatever I do to the bottom, I have to do to the top in order to not change the value of the fraction. And n-5 over n-5 is technically 1. So I haven't changed the value because I can multiply anything by 1 and still have the same value. It just might be expressed differently, as in this case. So on this second part, in order to get a common denominator, I have n-5 as the original denominator, and if I multiply it by n-4, now both the first and last fractions are the same. Whatever I do to the bottom, I must do to the top in order to not change the value. So now all I'm going to do is distribute 5 to the n-5, which gives me 5n-25. And make sure you're very cautious about this. This is actually a -3 technically, and you want to distribute that to both the n and the -4. So -3 times n is -3n, and -3 times a -4 is a +12. And then all of that's written over that big denominator that we created by getting a common denominator. And now you'll combine like terms. 5n minus 3n gives you 2n. And then -25 plus 12 gives me a -13 all over that big denominator. And that is your final answer for number 15. And I'll keep working unless there's any questions. A lot of these on this particular worksheet are very similar. You've got a very small factor on each one. So getting a common denominator is really pretty simple. The common denominator for number 14 is going to be k minus 4, k minus 1. So for that first fraction, k minus 4 times k minus 1. And whatever you do to the denominator, you need to do to the numerator in order to not change the value. And this one, you're going to multiply the top and the bottom by the k minus 4, which is the missing factor in the common denominator. And you'll just distribute. So 4k minus 4. And then this is a negative 5, making sure you distribute that negative to both pieces inside the parentheses. So negative 5 times k is negative 5k. And negative 5 times a negative 4 is a positive 20. All over k minus 4, k minus 1. Combine like terms, 4k minus 5k is a negative k. And negative 4 plus 20 is plus 16, all over the denominator that we made by combining both of the factors. Okay.
So does the negative in between the two, I guess, fractions, does that not distribute to the denominator?
No, that's an excellent question. I'm really glad that you asked that. It does not distribute to the denominator.
Okay.
And the technical reason, couple reasons for that would be that, let me erase this part so I can kind of explain that. With a negative fraction, only the top or the bottom have to be negative. And since we're distributing it at the top, we don't have to worry about the bottom because, like, let's just say 5, just to make this simple, I'm just going to use numbers instead of bringing in letters. But negative 5 over 1 gives me a negative number. Or a 5 over a negative 1 gives me a negative number. So with a fraction, only one of them has to be negative. And since we're technically subtracting the top, you don't really want to mess with the bottom because technically this is a subtraction problem, so it only applies to the top.
Oh, that makes sense. Thank you.
No problem. Great question, because that actually has been a stumbling block, I think, for a couple people I've noticed. So thank you so much for bringing that out. All right, now number 13. Once again, both of those are in their lowest terms as far as factors are concerned. You've got an n minus 5 and an n plus 1, so that's as small as you can go. So the common denominator is going to be 4. And this is so much like the other one, so it kind of, as far as numbers are concerned, because they both have a 4 and a 5 in the numerator. So, but it's n minus 5 and then n plus 1. And then we've got to multiply the top by the n plus 1 because we've multiplied the bottom by that. Don't want to change the value of the fraction. And then you've got 5 over n plus 1. And then I'm going to multiply that by the missing factor, which is n minus 5. And whatever I do to the denominator, I need to do the numerator so that I don't change the value. And now I'm going to distribute that 4. So on the left-hand side. So I've got 4n plus 4. And then I'm going to distribute this 5, which technically is a negative 5 times n, which is going to be minus 5n. And a negative 5 times a negative 5 is going to be a positive 25. All over n minus 5, n plus 1. And then I'll combine like terms. That's 4n minus 5n, which is going to give me a negative n. And then a positive 4 combined with a positive 25 is going to give me a positive 29. All over n minus 5, n plus 1. And that's your final answer for number 13. Moving right along. Number 12. Once again, it's already in its lowest terms. Both factors, both of the denominators can't be factored anymore. So pretty simple to start. You've got v minus 1, 6, and then you're just going to multiply it by the other denominator, which is v plus 2, plus 6 over v plus 2. The other denominator is v minus 1. So now you'll distribute your 6 to the v plus 2. So 6v plus 12 plus 6v. The addition are a little easier because you don't have to worry about distributing that negative. But 6 times a negative 1 is negative 6, all over our common denominator of both of our factors. And then we've got 6v plus 6v, which is 12v, and then 12 minus 6, which is plus 6, all over v minus 1, v plus 2. Now, in this particular case, you could actually take a 6 out of this numerator, and it would look like this. But either answer is perfectly fine, and Miss Stone and I will take either answer on the test. So if you left it in this form here, that's fine. But if you wanted to go ahead and factor it further, you could. And one of the reasons that you might want to do that is there is a slight possibility that your final answer, there might be a factor that would cancel out from something in the denominator, which in fact you could then do. But in this case, it doesn't. So either one would work. So just as an exercise in factoring, if you wanted to, you could do that. And if there are no questions, I'm going to keep moving. Is everybody good?
Yeah, I got it.
Okay, good. And if somebody writes, how many of you can see the chat bar?
I can see the chat bar.
Okay. Has anybody asked a question?
Not yet.
I'm sorry?
No, not yet.
Okay, cool. Thank you. Okay, number 11. On this one, really, in all honesty, I wouldn't need to factor it because obviously the understood denominator for 3 is 1. But just for the practice of factoring for you guys to say this is typically what I do when I'm approaching these problems, this would just look like this. That way, if I needed, I needed to incorporate another factor somewhere else, I could. But so that you just kind of want to make sure that that's an exercise that you're going through when you approach these problems. But in this case, what you're going to end up with is you're going to have 3 over 4 times n minus 1 times 4 times n minus 1. And I know that that looks like a big thing. I'm just trying to show you how you need to approach every single problem so that it's not different for you. Oops, my bad. So then up here, I'll have 12n minus 12 plus 4 all over 4 times n minus 1. And then that's going to be 12n minus 8. Which then would break into 4 at the top times 3n minus 2 all over 4n minus 1. Nice writing, Miss Sparks. And so one of the reasons that you would do that is now you see that 4 cancels out. So your final answer is 3n minus n minus 1 on the bottom.
I had a question, not
Yes,
about
sir.
this one, but the ones prior to this, where you write the denominator twice for each fraction. Can you just like use only one denominator, or do you have to like write it twice?
On what?
On number 12, or I'll use 13 for example.
Yes, sir.
4 and then in parentheses n plus 1 over n minus 5 in parentheses and then n plus 1. And you did minus 5n minus 5 over the denominator again.
Right.
Like, could you just do like 4 in parentheses n plus 1 minus 5 n minus 5 on the top and just do one denominator on the bottom?
Oh, yes, sir. You
Okay.
could absolutely do that if you can skip that middle step for yourself and it not cause you a problem. You can absolutely do that.
Okay, so I think that there's like a reason. Okay, thank you.
The only reason that I typically do that is to show what that middle step is, to show why I'm doing it. Because the main reason that I write it twice is I show the actual work of multiplying the top and the bottom by the opposite. Does that make sense?
Yeah, it does. Thank you.
Okay. All right. So now number 10. Does everybody want me to just keep working straight through or skip some?
That'd be great if you just kept going through it.
Oh, okay, cool.
I'm not speaking.
Okay, so on this particular one, if you want me to, I'll do it your way, Chris, if you want me to. Instead of writing the long fraction bar, is that what you're saying? So instead of
it's whatever.
Okay, so make sure that I'm answering the question by doing it this way. I've created the common denominator, which is going to be 5 times p minus 6. And over here, this 4p is going to be multiplied by p minus 6 to make up the difference. And on this side, I'm going to have p minus 2 times the 5. Kind of. And then I'll do 4p squared minus 24 plus 5p minus 10. Is that what you mean? Did I do it the way you were asking?
Oh, yeah, yes, ma'am.
Okay, cool. So now I have 4p squared plus 5p minus 34. Is that what you got so far too? And now we get to factor this. I know that's some of y'all's favorite things, right? Unless I did something wrong. This is where, you know, that, 24p, that simple mistake. Which is going to be minus 19p. Minus 10. And I'm trying to think, that would give me a 40. And I can't think of any factors that multiply to give me 40 that when combined give me a negative 19. So you could leave it in this form, because the only thing that you would be trying to look for is something that you could possibly cancel out from the 5 and the p minus 6. Okay?
Wait, have you been math labbing our whole study session with Sparks?
Yes, I'm so sorry, Chris.
What did you say? He's home with you.
Y'all are crazy. Okay. That was number 10. And now we're moving to multiplication and division, moving to division, but which y'all didn't like those at first, but now I feel like everybody likes those a little bit better now that we've done addition and subtraction. But on that number 9, you're going to want to keep, flip, change. So typically, while I'm rewriting the keep, flip, change, I go ahead and write out my factors. So r squared minus 11r plus 30 factors into r minus 6, r minus 5. And then times, and this is where I'm going to flip this over, and I'll have 4 over 10r. And now this is where I'm going to look for things that cancel, and you can cancel top to bottom or diagonally, but you cannot cancel horizontally. So your 10r cancels, and it leaves you with 4 over r minus 6, r minus 5. That's 9. And now number 8. I've got x minus 6. We're going to keep, flip, change, and I'm going to factor at the same time. Something I want to point out to you guys, if you can't already start to see some of these patterns, I would ask you to try and work on seeing patterns. This right here, y'all should, when you see that, that's 2 squares on either end with a subtraction in the middle. That's a special factoring, which is the difference of 2 squares, which is x minus 6, x plus 6, and then times, and then keep, flip, change tells me the top is going to be x minus 4, x plus 1, all over 1. The only thing that cancels here is the x minus 6. So your final answer is going to be x minus 4, x plus 1, all over x plus 6. Number 7. Once again, I'm going to factor as I write my keep, flip, change. And the top factors to be x plus 7, x minus 4, all over x minus 7, times And then this is going to be on this side. I'm going to flip my fraction. It's going to be x plus 6 on the top. And the bottom is going to be x plus 6 times x plus 7.
Oh, so even though you're dividing, it's multiplication still?
Well, I keep flip change.
Okay, that makes sense.
So what I was doing at the same time was writing them out in factors. But this second one right here, while I was writing its factors, I went ahead and flipped it and moved the top to the bottom. Because
yes, ma'am.
Okay. All right. So now I'm going to look for things that cancel. The x plus 6 cancels here. Once again, you can cancel top to bottom, but you can't cancel horizontally. You can cancel diagonally, though. So this x plus 7 can cancel with that x plus 7 over there. And that leaves me with x minus 4 all over x minus 7. And that is my final answer for number 7. Number 6 is straight multiplication, so I don't have to worry about doing the keep, flip, change. I can just go ahead and factor it and look for what cancels. So this changes to k plus 7, k minus 6. Oops. That's what that one is. And so these actually cancel. And that cancels. And the only thing you're left with is a 4. And that's your final answer.
For that one?
Yes, sir.
For the factors of 42, couldn't you technically do k minus like 1 and then k plus 42? Or I mean k minus 42 and then k plus?
That's a good question. But when factoring, you need the key thing to remember is you're looking for 2 factors that multiply to be this, but when they're combined by adding them together would give you a 1k. So if I used a negative 42 and a positive 1, I would be ending with a negative 41.
Yeah. Thank you.
So yes, those factors work for the multiplication side, but they didn't quite work for that middle piece. And that's, you get that middle piece. I don't know if y'all remember foiling real clearly or not, but that's where that middle piece comes in. All right, number 5. This top part factors to be 2x times x plus 7. And so this 2x cancels with that. And so my final answer is x plus 7 over 9. Number 4. This factors to be 6x times x. Well, was this? Now that I crossed it out, I can't tell whether it's a minus. Minus 2. And then this is x minus 5, x plus 2. Nope. X minus 5, x minus 2, because minus 5 times minus 2 is a positive 10, and a minus 5 and a minus 2 add up to be a negative 7. So now we're looking for things that cancel, and the x minus 5 cancels with this x minus 5, and this x minus 2 cancels with this x minus 2, and that leaves me with 6x over x minus 3. And that's your final answer for number 4. And graphing. On the graphing, on the more complicated ones, the ones that have lots of letters and numbers on the top and the bottom, you need to factor. But before we factor, we'll just go ahead and address the horizontal asymptote, which on that particular sheet that Miss Stone and I gave out, the 8 legendary steps of graphing rational expressions, the horizontal asymptote is the part on these more complicated ones where you're going to compare the degrees of the leading term in each expression. So you always want to make sure, first of all, that they're in descending order, meaning you want your highest degree term starting first, which in this case it does, because you've got it raised to the 3rd power, and then the 2nd power, and then the 1st, and so on. So it's in the correct order. And now the next thing you want to do is compare the degree of the top to the degree of the bottom. And in this case, the degrees match one another. So because they're both cubed and they're equal, that means I'm going to take the ratio of the coefficient of the leading terms. And there's an understood 1 at the top next to the x cubed. So that's 1 over, and the leading coefficient, or the coefficient on the x cubed on the bottom, is a -2. So that says my horizontal asymptote is y equals -1/2. So my horizontal asymptote goes right along here. And what she and I are looking for on the test tomorrow is the fact that you know how to get the horizontal asymptote and you know to draw a dotted line on that graph. That's the part that we're really honing in on with regard to the graphing. The second part is going to be where you're going to factor that denominator. So in this case, the denominator, I can factor out a -2x, and it's going to leave me with an x squared plus an x minus 2, which then factors to x plus 2, x minus 1. So I set each of those terms equal to 0 asymptotes. And so my vertical asymptotes are x equals -2 and x equals 1. And so you would draw those in on your graph. And then sketch the rest of your graph. And there's technically a hole in this one, which you all will get in pre-calc, which, because the reason why it's a hole, and like I say, you won't need to know this for the test, but just to kind of introduce that concept to you, when you factor the top, you actually get an x squared, x minus 2, and at the bottom, you've got this 2x. So one of these x's cancels, and that is at 0. And that's going to be a hole in the graph. But you won't have to know that for tomorrow. I'm just trying to kind of introduce that concept to you so it's not completely foreign next year when you're in pre-calc. But that's what that graph looks like. And the most important thing, the things that we are looking for, is those vertical and horizontal asymptotes. So if you have a question about that piece, also one other thing I want to caution you, if you're trying to plug these into your graphing calculator, which is perfectly fine, it will not give you your horizontal and your vertical asymptote. So you do have to know how to get that on your own. But I caution you to make sure that you are putting parentheses around your top and your bottom. And I'm going to actually plug this into Desmo so y'all can see how you really need to make sure you just put in a lot of parentheses. So you'll notice I typed 2 parentheses and I've got x raised to the 3rd power minus x squared. And then I'm going to just type lots and lots of parentheses. Because if you don't, you won't even get close to what the answer is. You'll get all kinds of squirrely graphs. And you'll also get to see that how ugly my sketch of the graph is. And you can't even hardly see that middle one. But make sure you're plugging in and I probably plugging in all of the parentheses everywhere you go. On that sheet, also, the last 2 on this review sheet, they are the simple rational expressions that we did in 5.2. And they have a different general approach than the more complicated ones. This was from 5.3. The simple ones, once I get all this erased, I will remind you guys of what the parent generic formula is for the simple. Because there'll be 2 of those on the test tomorrow. And they look like it's f of x equals a over x minus h plus k. And the vertical asymptote is x equals h, and the horizontal asymptote is y equals k. So in this case, the horizontal or the vertical asymptote for this one is going to be x equals 1. And the horizontal asymptote, since there's nothing there over here on that side, it's going to be y equals 0, or the x-axis. And so your graph looks like this. And on this one over here, it's going to be vertical asymptote is x equals 2, and horizontal asymptote is going to be y equals -3. So it will look like this. Oh, it's a negative out front, so you're going to flip where those are too. That negative out front flips where you write the graph. Are there any questions?
Yeah, I just had a question on Tuesday's homework.
Okay.
Number 5, I could not figure that out.
Okay.
I don't know if you can get to the Tuesday's homework.
I can.
Okay, cool.
This is what you were talking about?
Yeah.
Okay. All right. On this one, it was loaded.
Yeah.
What you're going to want to do is factor each individual one into its smallest terms so that you can make sure you're incorporating each individual factor into the least common multiple.
Okay.
So this case, you would pull out a 4.
Okay.
And that would leave you with x plus 7.
Okay.
And on this one right here, that actually is going to leave you with 4 times x squared plus 11 x plus 28, which then factors down to x plus 7, x plus 4. And over here, that leaves you with x plus 7. So,
okay.
This being the case, right here, this whole big long thing is going to be that least common multiple that you're going to multiply both sides of this equation with. Okay.
Yeah.
So what I'm going to do then is, how many times will this go into this, or what would be left over?
The x plus 4.
Yes, sir. Good job. So you've got x plus 4 times 1, which is x plus 4.
X plus 4.
And then
minus 1.
And then on this one is just going to be minus 1.
Right.
Because that actually cancels each other out. Now on this 2x plus 7.
You multiply by 2 and then by x plus 4, right?
And well,
because
2, and then you have to include this 3 also.
Yeah.
Because and then x plus 4. Absolutely. Perfect. Good job.
Okay.
All right. And then I'm going to erase some of this so I can keep working down. Sorry about that.
That's a big problem.
And then I'm going to start combining on this side. So I've got x plus 4 minus 1, which is going to give me x plus 3. And then I've got this 6, and I'm going to distribute that to inside this x plus 4. So that's going to give me 6x plus 24.
Okay.
And then I'm going to start combining things on both sides of the equation.
Okay.
Which, if I move everything over, move my variable to the left, which seems to be most user friendly for students, that's going to give me a negative 5x. And if I move this 3 over here, it's going to give me a positive 21 because I'm going to subtract 3 from 20.
And then you divide the negative 5x, and then it's x equals negative 21 over 5, which is the answer.
Yes, sir, it is. Okay, perfect.
Awesome. Okay. Thank you. The thing that I did was, like, instead of taking out the 4 on the second fraction, instead of taking that out at the beginning, I just tried to factor it. And then
bless your heart. Yeah, that would have been a humdinger.
Yeah. But definitely thank you. That was awesome.
Oh, hey, no problem. Any other questions?
No, that was the only one that I had trouble with.
Okay.
Thank you.
Oh, not a problem. Thank you.